Essential ici dit
Can you hear me?
Yes, yes, I can hear you.
Okay, great. Okay, so let's start with a little bit of delay this workshop, this session of the German Month conference today within the ICCSA conference. We have 4 presentations scheduled today, but at present we have 2 of them that are going to be delivered. Marion, if you would like to come along and do your presentation, you have Mario, Simone, and Arnold Ash building a rule-based generalization service for visualization of business data. So, if you like to come along and present your paper, you can actually come here because the first presenter is not yet connected. And afterward we have Ivan Ablecic with the Evaluation Territorial Center, Capital of Fragile Territories, the case of Sardinia. But let's start with Mario. If you can allow 15 minutes for your presentation, and maybe 50 to 20 minutes, let's say 20 minutes, and we have 2 presentations left. So whenever you like, you can start.
And this one is no, forget this one. Yes. Where's the camera? Good morning, everybody. I can introduce myself at first. My name is Marion Dorothee Simon. I'm coming from Germany, from the University of Potsdam. And what I will present today is an option to gain more information from business data through maps that's optimized by a generalization service. I know you are all scientists and you are good in imagination, maybe especially at this early time in the day. But now please prepare your mind to change your role. You're in a company, you're a sales manager, and you're responsible for exports for certain goods. And your company is nearly the only one in the country, and the competing companies are known to you. So you have to do a lot. Among other things, you are responsible for, let's say, the Scandinavian market. And today, it's a busy day, as always. And your boss comes and say, "Hi, Chris." Or Pivo, Beniamino. What do you mean, according to your experience so far in the last 2 years, handling with our new clients from Scandinavian countries? Is there a potential to increase our exports in the short term? And he thinks he's stealing clients from the other companies. He would like to. And also he don't like pie charts. Therefore, you push a button in your new implemented business intelligence. Oh, I'm sorry. Yes, that's right. Yeah, I'm pushing right. You missed anything. So you push the mapping button in your data discovery system or business intelligence system that includes the mapping tools or functions. And what you see is this. Everything's working. You see nothing, but it's not because of my bad presentation. No, it's the problem that standard default settings of systems considering neither parameters for map presentation as size or scale, nor export or representation parameters like size of the paper or screen size. Then you scroll a bit to see a bit more. And what happened now? You see diagrams for a certain good, let's say breakfast and chocolate spread. And you know the lighter part of the diagram represents the import figures from each country. Here say Norway, Sweden, Finland, and the darker part of the diagrams represents the exports from your company to the Scandinavian countries. So you can see the potential of the market for your own company, and you see the competing companies in the lighter part. But your eyes are lost in the map because you see in Norway, especially, a lot of fjords. And what do fjords have to do with chocolate spread? Nothing. So this is the core of generalization, to eliminate the things that are not needed to represent your theme in a map. So you need something better. You have some, for this better, you have several requirements. As an example, it should guarantee quality, even if figures are changing. But what do you think what happened with Denmark, for example, if they increased their incomes? They disappear. They disappear behind the diagram. Another requirement. You have to eliminate the shape of the not needed what the boundary. You have to simplify the boundary of Norway, for example, because your eyes are irritated by the fjords. So what you need is an effective visualization model. And for the following slide, we'll do a test. Now you switch from the sales manager to the boss. You are the boss and you are interested in the market potential of the Scandinavian countries, and your key account manager is about to show you the visualization model from the following slide. Please do me the favor, in count of seconds you need to understand the visualization. The high score you have to break are 8 seconds. Oh, that's 8 seconds. This one. So was faster than 8 seconds? Maybe. Why it was so fast, 8 seconds? It is an effective visualization model. So the intuitive interpretability is in a few seconds possible. Thank you for your attendance and your attention. Now I need you as a scientist again, because I would like to show you how this transformation will succeed. You put the map image from the first slide through a generalization service, and what you get is what you see at the last slide. But why I found this service? Well, we had to build it because that's what our contribution is about. Building a rule-based generalization service. And the shortcut of it, I represent you now. What's inside? It's a simplification of the shape I told you. And what we did is to adjust the coloring and the size of the diagram depending on the information and the scale output requirements. We do 5 steps. First, we build first of all, I compiled a generalization rule catalog. Rules like there should be a minimum distance from a certain size 1.7 millimeters, for example, between objects or within objects to recognize the shape, for example, of Norway. The fjords have to be a certain size. Afterwards, I identify the conflicts. So where are, based on the rule, appearing conflicts. Then we describe the solutions. There are some options to search for in platforms like Stack Overflow or something, or programming language specific solutions that could be adapted or could be implemented in the service. Afterwards, there is process modeling following. Oh, sorry. And afterwards, you see the implementation in three steps. So the first step was I had a rule base and I have to check it first. Check the distance, for example, like 1.7, and everything that's smaller disappears. For example, the islands or the small, you see distances in these fjords of Denmark. So the process starts, and in the end, compare with the constraints of the rules and suggest a solution. That looks like that. On the left side, you see the solution for Denmark. There are no fjords, no holes or something, no islands more. But for the export parameters, it's exactly this, because it's smaller than you see it right now. And if you scroll in and scroll out, then you see Denmark as it is, as you need it for putting on the theme on the base map. So what does the rule-based generalization service mean? It means the improvement of map communication. It supports informed decision-making for companies, because the bosses don't have to scroll in and think hard and searching for the solution. And very important, I think, the process will fill gaps between the research results and existing, or to adapt specialized tools for generalization services. So I thank you a lot for your attention, and maybe you have questions.
Okay. Thank you, Mario, for your presentation. Is there any question about this presentation, about this topic? I got a question. Did you test this kind of generalization also with some business person asking about the perception and the effectiveness of your proposal?
Not a boss, but sales manager. Yeah.
Okay.
Yeah, and therefore there was the 8-second record. Yeah.
Okay.
Yeah. that was, and they don't have actually no map button on their SAP or just something, data discovery systems, etc.
Okay.
They don't have a map function, but there are SPSS maps, SPSS or other data handling systems with a map option. But the quality that comes out is not that you can understand effectively what do you want to transport in the thing. Yeah.
So we need to appreciate your proposal and your option. So
yes, it was to increase the quality of those buttons, or should be implemented, but because one picture says more than 5 words or something. Therefore, this picture has to be increased and have to be effective.
Okay. Okay, great.
Thank you very much.
Thank you very much. Thank you. Okay. Good. So we can actually move. I don't know if there is another. Okay. We can do anything. Can you just interrupt us?
The next speaker.
Yes, no, but we have even, okay, so we move to the next presentation, that in this case, our friend Ivan, I suppose, because we haven't got the other two presenters. So, Ivan, is your turn. Whenever you like, you can
Sure.
start your presentation. And we are,
Okay.
can you see the all of us, but there are a number of friends here eager to listen to your presentation, okay?
Thank you.
So,
Thank you, Giuseppe.
15 to 20 minutes for presentation,
Good.
and the room is yours, okay?
Good. Thank you. Thank you, Giuseppe. Thank you, Beatriz. Good morning, everybody. Let me share my
Can you manage
presentation.
to share your presentation, Ivan?
Yes.
Okay.
Okay. I hope you can see my.
Yes, okay.
Okay, good. So I'm gonna talk you about, tell you a little bit about this recent research that we have done in evaluating territorial capital for fragile territories. Okay, just a little introduction what our topic is. We are actually working on this issue of so-called inner areas, which is a phenomenon present in many European countries. And in Italy specifically, there is a national strategy aiming at policies, development strategies for dealing with different issues related with these inner areas. So what are these inner areas? These are basically known coastal territories. You can see a definition here, usually with historical settlement, which are distant or poorly connected with major urban centers. And they're especially in mountainous and agricultural areas. So these areas, you can see them here on the map of Italy. These blue, different shades of blue are either intermediate, peripheral, or as they call it, ultra-peripheral areas, which has these characteristics. And these features are related to demographic stagnation and general economic decline. So these areas has been an object of attention for some time now in Italy. And what we try to attempt is to develop a more sophisticated assessment procedure and tools for evaluating the development potential of these areas, because our premise is in a way that not all inner areas are created equal, and so we need to classify them to manage to understand which areas would need to be handled with different kind of policies, depending on their condition, on their development potential, and on their so-called, let's call them opportunities and capabilities offered by these territories for the development. So we settled to try to give a more operational definition of so-called territorial capital. Now, this is a little bit contested word and terminology, but this term appears in the National Strategy for Inner Areas many times, and here you can see a definition how this concept of territorial capital is defined and used in this the national strategy document of the national strategy. So it basically says that for the construction of a strategy of economic development for inner areas, this territorial capital should be taken as a starting point. And the concept of territorial capital is really wide, including natural, cultural, cognitive, social energies, productive systems, features of the local populations, and so on. So it is mentioned, it is used as a kind of a pivotal concept, but it is never formally defined. So this is what we, in this research, what we try to do is to try to specify how we could measure this territorial capital and how we can then use this analysis to classify different inner areas based on their development potential. So this is what we came up with. Basically, we said, well, if there is a territorial capital, maybe we can subdivide it into sub-capitals. And here you can see 8 territorial capitals that we measure and evaluate. So human capital, social capital, cognitive capital, infrastructural capital, productive capital, relational capital, environmental capital, and the settlement capital. Every one of these has been developed through a set of indicators. So let me go through a couple of them so that you get the idea. We gathered a lot of data, drawing for open data databases that are available both from the National Statistical Services, regional services, all sorts of sources. So let's say social capital, we defined this set of indicators which are meant to be like a proxies of what is usually meant in literature by social capital. So the voting population, the number of voluntary association, the amount of expenditure for social services, and the number of users in the social educational services. For cognitive capital, the third one, we have culture. We measure cultural and recreational services, the expenditure for cultural accessibility or availability of broadband connections, and the association of social promotion. So as you can see, every one of these has been defined with a set of, let's go through the environmental capital, for instance. So the amount of park and protected areas, the agricultural areas, if there is some hydrogeological risks, the waste sorting, the social sustainability, sustainable energy, renewable energy production, and so on and so on. So you get the point. We gather the data, we put them together, settle them in as a component of these 8 capitals, and then we made some specific modeling and aggregation procedures among those indicators. So there are 8 categories of capitals, as I just showed you, which are calculated at municipal level. Now, this is something that I will come back to. There is an external scaling for each sub-indicators that you've seen. So we basically, on each indicator, we defined based on literature or on our expert knowledge, what is the threshold for the optimal value of that specific sub-indicator. And then the data has been scaled so that they get normalized and they become comparable. One interesting thing that we added, and maybe this is even the most interesting, I believe, concept that we've implemented in this model, is that the one on the bullet number 4, And it is that we added geographical and proximity averaging or diffusion of some indicators. So basically, usually when these maps are done in other experiences, in other researches, they are measured at municipal level, but there is no geographical interactions between these municipalities. So you can just calculate them in a spreadsheet. There is no geography in a proper sense. What we try to do for some indicators which are meaningful, so that some services that are, for instance, to give an example, some services that are available in one municipality might have a spillover effects, or might be services available for nearby municipalities, let's say municipalities which are 20, 30 kilometers farther away. And so we distribute the effect of that availability of services in that municipality to the nearby area. So we have this geographical or proximity averaging, which seems to us an interesting concept to include a little bit more sophisticated geographical interactions when you think about, when we think about devising strategy of, I don't know, providing territories with services, with health services, educational services, and so on. We put all this together in a web mapping platform, Mango, and this platform then allows you to manipulate. It would, in principle, allow you to reweight the different indicators and to aggregate them specially by different administrative divisions. And it can also produce historical series and custom maps. So basically, this is something that I will now show you in my last 5 minutes. I will give you a live presentation of this web-based GIS. So let me just, Giuseppe, switch to the other screen. Just a second. I hope you still see me. Okay, let me switch the other window. Okay, so this is basically the live platform where all this data are stored, and it is already available. So as you can see, this is the first, the home screen with 8 different capitals: human, social, cognitive, infrastructural, productive, relational, environmental, and settlement. And then there is the final aggregate map of territorial capital, which aggregates in a single score all the 8 capitals. So let me go through some of them just to show you how the system works. I enter into the social capital, let's say. Here is you should be seeing the map of Sardinia. You get the distribution of the scores. As I told you, the scores are scaled on a scale to 0 to 1 to improve the readability and comparability. These maps also shows you the sub-indicators, which are the overall social capital index is composed. So if I want to see the amount of voters on local elections, you get this map over as a layer, so you can see them all. Let me go back to the social capital. If I want to pick a specific municipality, whatever, any one of these, let's put Senis, okay, you get details, the overall score, the individual sub-indicators, and the comparison. Here you can see also graphically represented the values of individual indicators. So you can do this for any municipality. I will just randomly click so that you get the feeling what this tool can allow you. Let me go just to show you another one, like environmental capital, which tells you, well, opportunities, interesting, environmental protected areas. Again, as I told you, if you click on one municipality, you can see all the sub-indicators that it is composed of. So as I told you, parks and protected areas, surface used for agricultural production, risks of hydrogeological risks, the waste management, and the production of renewable energy. And you can go to these maps. you pick this URL, you can explore it yourself. Of course, I can share it also in chat if you're interested in this. Let me finally go to the last definitive map, which is an aggregation of all the individual capitals. So this is, for us, the map of the territorial capital of the Sardinia region. Again, you can go into clicking on each one, explore. You've been to Cagliari last year, so let's go to Cagliari, just virtually. Many of you has been to ICCSA last year here, and it tells you, well, all the single individual capitals, which are again eight indexes, and the aggregate value, which is reported here. Okay, so that's more or less what I want to tell you about. Of course, this is a platform and research that has been developed as a prototype, and we now are in the middle of discussion with the regional government to define the possibilities to make this a permanent and maintained platform, and its usefulness, well, besides many different developments that you can imagine can be added. What's interesting is that we devised this platform as a tool for policy making, so that you're able to do this fine-grained and detailed analytics, and maybe this could be useful for defining tailor-made policies for individual territories, individual municipalities, individual provinces, based on the results of this analysis and based off what seems to be the lacking component of each territory. Okay, Giuseppe, I think I was on time.
Great, thanks, Ivan. You've been perfect in time. Okay, is there any question from the public about this presentation? Yes, Mario?
I have the question if...
Hello, I can't hear you.
I can't hear you.
Would you like to come along here so that also here? So I think that if you come here, Ivan can see you, and yes, if you just screen because the camera is there.
Hi, Ivan.
Hello, Maridon.
My question is if you can, I think, because you developed the generalization problem. But what's in my, it's not a problem at all, but for example, the coloring of the categories of your, what was it, environmental and social and stuff, it seems to be a bivariate scaling that could be interpreted from your coloring. But instead of bivariate, it could be very contrastful colors, for example, because the social thing has to do with the environmental, and when it's orange and the next one is yellow, then it's grading, you know, and that it's not what you wanted to tell, I think. Therefore, do you think is it possible for you to change the coloring? Do you understand what I tried to say?
Sure.
Okay. Or is there a reason for this?
Sure. Well, in principle, yes. So it is, of course, the age-old problem of visualizing data and devising the meaning of what the data are showing to us. Yes, we were a little bit conflicted what kind of coloring to use. It is always a little bit complicated to declare a territory the deficit that might not be there. But I agree with you that yes, we could maybe explore different chromatic scale palettes for the values of for the representation, and also different strategies for cutting the interval from 0 to 1. Because again, this is something that is even more relevant. If these cuts are made now, they are crisp, We could do all sort of nuances, because sometimes basically what you've seen on maps, there are 5 levels, but again,
Yes.
it's different. 0.8, it's different from 0.9, although it falls into the same category. So yes, we should be careful when we are devising this. What is interesting is that, of course, I didn't have too much time to go into the specific way we've aggregated, we've rescaled the data. I think you just got the general impression. These indicators are usually numeric values, so they are continuous values. And so, yes, when you go from continuous to discrete, there is all sorts of attentions that should be put into it. But I agree, yes, we could do red and reddish or more warmer colors. I absolutely agree with you. We should play with it, I'm sure. Yeah. Thank you. Sure.
Thank you, Mario. Thank you, Ivan. Is there any other question? Okay, so I got the question actually, Ivan. Well, found the project really interesting, and while you were talking, I was just having a look at your maps here on my PC as well. I did catch your website. I roamed a little bit on the web GIS. I did imagine, as the topic is particularly up to date and important in the current debate, and of course, it is I think that it is one of the major issues that we are facing at territorial level, particularly in some regions, and I am particularly aware of that because both Sardinia and my region are quite known for the problem of inner areas, particularly in the internal part of the regions, in the mountain areas, etc., etc. Did you, by compiling this web GIS, do you have a kind of flavor of what could be a level in which you could draw a line and let's say highlight what could be some cluster or some more than a cluster, some possible set of other inner settlements that could be the target of let's say of policies or of some kind of boosting of the economic activities, so that they could play a different role than just an inner area.
Yeah. So as I was trying to kind of convey the overall objectives of this research at the beginning of my presentation, what we have found out is that the first map that you've seen of the inner areas is actually more obfuscating than telling what is happening on the ground. Yes, these areas that you've seen in blue at the beginning of the presentation, they all have demographic decline. They also have some general common features. Nevertheless, and this I think is the most interesting question in terms of policy, nevertheless, these areas are very different in terms of their development potential, in terms of their current capabilities, and in terms of the ingredients that might be missing to devise that might be missing and therefore be the target for specific policies to improve the conditions for potential for development. I am not too much keen on policies that directly produce demographic change because you have to deport people, for instance, which is something that we don't like to do. What we try to think is to provide specific infrastructures, opportunities, capabilities to territories, to let them spontaneously, to give them the maximum possible chances so that some kind of spontaneous demographic, economic, social activity takes off and turn it into a not inner area. So I agree, if we go and see these individual municipalities, you discover, yes, they are all classified by the national strategy in the same way and sometimes targeted by the same policies. But what you can discover with this kind of analytics, and it would be interesting to develop it for your region, for Friuli Venezia Giulia also, is to see that every municipality, every province might need different kind of features which are missing, the missing ingredient. So some areas needs better transportation infrastructure, some area needs broadband, some areas needs educational services, and so on. So you can have this kind of a tailor-made policies. And this, I think, is, at least as a potential, the most interesting output of this kind of analysis. So yes, I agree with you. And maybe we'll have chance, because what we tried to connect and all the available, almost semi-automatically, the available data sources from different open databases. So it might not even be too much work to now develop a map of Friuli Venezia Giulia, of Umbria, of, I don't know, Puglia, and so on and so on. The idea is that this methodology can be easily transferred to other regions in Italy and in principle in Europe.
Okay, thank you, Ivan.
Thank you.
Thank you very much. I think that we haven't got the other two presentations, so I thank the two presenters today, and thank you to the public that is here in presence in Malaga and at home. Ivan, thank you again, and I hope to see you again in the next sessions at ICCSA.
Yeah, thank you.
Bye-bye. Thank you for in presence, and okay, have a good rest of the day and the ICCSA conference. Thank you. Okay. Thank you, Beatrice. Cheers. Thank you very much. Ciao, Ivan. Ciao, Ivan.
Ciao, Ivan. Thank you.
Francesco, ci senti?
No.
Non so
Sì, vi sento.
Sì,
Vi sento, vi sento.
Ah, ok, ti stavo provando da un po'. Ok,
No, voi mi sentite?
Sì.
E credo mi vediate anche.
Right. So can you see this? Can you see the audience? No.
No, we can't see the audience, just the first person.
Okay. Shall we start?
Yeah.
I guess so. All right. So welcome to the second session of the GeoAnMod track here this morning in Malaga. For this second session, we have 3 virtual presentations and 1 presentation in person. And I guess this is the first presentation, which is done by Francesco Rotondo. So we'll give him the floor. Francesco, the floor is yours, please. Your mouth, okay.
No, okay. Here I am. Thanks for your presentation. I'm trying to share. I'm trying to share.
Let's see. Okay.
Do you see my presentation?
Yes, we can see that clearly. Thank
Perfect.
you.
Okay. So we can start. Our paper has tried to use the SDGs indicators for a statistical analysis of land and water resource protection. Because we have thought that the evolution of the concept of sustainability and a large availability of new statistical information needs constant checks on the set of indicators that we can use to represent what we can call well-being in our society. As we know, Sustainable Development Goals normally refer not only to environmental matters, but also to social, economic, and institutional issues. In the environmental sustainability is particularly interesting and also relevant, as we know in these days where we need water, that territorial protection and water resources issues are very, very relevant for us. That's why we have tried to understand how statistical indicators can be useful for urban planning and decision support systems. That's why we have chosen to analyze the data available at the regional level, in the case of Italy, through a multivariate statistical methodologies and particularly total fuzzy and relative method, capable of synthesizing the multiple information that we need to assess the water and territorial resources in different Italian regions. So, the presence of these multiple data, all updated in 2019, allow us to research an approach capable to integrate the evaluation of the policies in the government of the territory, in territorial governance, so that we can analyze also the consequence policies taken from the Italian government. So, the 2030 agenda, as we know, it consists of 17 objectives divided into 169 targets that refer to different domains of economic, social, and environmental development. And the United Nations Interagency Expert Group on Sustainable Development Goals in 2017 proposed a system of over 230 indicators necessary for monitoring the successful in gaining these 17 large and general objectives. And this is the reference framework for our work. In Italy, the National Recovery and Resilience Plan is the Italian agenda to realize the next generation European Union program, and its 750 billion euro package to overcome the pandemic crisis. This plan, you know, is developed around 3 strategic axes shared at the European level and 6 missions. The subject of territorial safety, it hasn't an autonomous space, but it is in some sense shared, integrated in all the 6 missions. In these missions, the prevention and restoration interventions in the face of significant hydrological risks, the protection of green areas and biodiversity, and the elimination of water and soil pollution and availability of water resources are main features to gain. So, what we have done, we have tried to analyze the sustainable development goals related to the different domains, and especially the goals considered for the purposes of the analysis for the protection of the territory and of the water resource, and then using them as criteria to analyze the situation in Italy that the recovery plan is trying to overcome, to resolve in some sense. So in this table, we are seeing the goals in the Sustainable Development Goals that are related to territorial and water resource protection. And we have then its indicators, and you in this table you see also their measures and their data source. Then we have analyzed different sets of indicators. The first one related to the protection of water resources, and in particular they are water supplied per capita, efficiency of drinking water distribution networks, irregularities in the distribution of water, and the coverage of the public sewerage service. And just analyzing these simple indicators, we see in this moment and in the 2015 situation, a relevant differences between northern and the center of Italy. For example, in the efficiency of drinking water distribution networks, we see that this is a percentage that in the north of Italy, they are nearest to 70%. In the south of Italy, they are nearest to 50%. Something like 15% difference. And if you think that it's different, meaning that that percentage of water is losing, you understand that this is a sort of territorial difference that needs to be compensated, needs to be more balanced. In the same situation, we have, for example, in the second set of indicators that we have taken from the Sustainable Development Goals related to the protection of the territory, waterproofing and land use per capita, soil waterproofing by artificial cover, fragmentation of the natural and agricultural territory, incidence of urban green areas on the urbanized surface of cities, something that is very related to soil consumption in some sense. We see, for example, that the incidence of urban green areas on the urbanized surface of cities is quite different from south and north. They have a 5% of difference from 11 to 5.5. So we have tried to analyze these different measures in an integrated way using the fuzzy approach, consisting in the definition of a measurement of a degree of membership of an individual to the fuzzy totality of the difficulty conditions in a range that is under 0 and 1. Mathematically, such a method consists of the construction of a function of membership to the fuzzy totality of difficulty. This function is subdividing clusters of difficulty, indicating the distribution rule of urban difficulty inside different urban realities that we have analyzed. So, supposing the observation of key indicators of poverty, or in this case of difficulty, the function of membership to the fuzzy subset may be defined using this formula. And the values of the weight that we use to integrate different indicators is this last formula. So using this method, we have tried to analyze the system of the two sets of indicators that we have considered, identifying minimum and maximum and the average value of each indicator of the two different sets. Then indicators have been transformed in the way that high values are significant for regional situation, and conversely, low values are significant for favorable conditions that not require public intervention to balance different situations. For each set of indicators, the fuzzy value and the relative values connected to it have been calculated, and also the weights of different criteria have been given using them to put in evidence differences between the different territorial areas considered. So high values of indicators of the fuzzy indicator that we have calculated put in evidence a strongly discriminating condition. As a result of this application, we have so classified Italian regions based on fuzzy values, obtaining classification that we will see in the next figure. And this figure shows that high values are significant for regional situation of water or territorial degradation, which therefore require national intervention. This is the result of the application of the totally fuzzy and relative method on the data of all Italian regions related to those two sets of indicators that we have shown before. And the synthetic indices that we have obtained using total fuzzy and relative method describes the territorial distribution of the indicators as represented in the figure. So, from this analysis, it emerges that for the set of indicators related to the protection of the water resource, most of the regions are in an average condition, while 3 regions have strong deficiencies in fuzzy values between 0.6 and 1, and they are all the 3 in the south regions of Italy. They are Molise, Calabria, and Sicily. So these show to us that effectively policies like European Union recovery funds need to be more balanced and more attentive to take into account these relevant differences between the starting situation of the different regions in Italy. For the second set of territorial degradation, the synthetic fuzzy index shows that there are 7 regions in condition of territorial degradation, and in this case they are more distributed on the entire surface of the nation, because we have Veneto in the north, Apulia region in the south, and then that are the worst situation in Italy, these 2 regions. And then we have Molise, Campania, Lombardy, Emilia-Romagna, and Tuscany that have yet high values after the first 2 regions, Veneto and Apulia. So, this situation of degradation is more distributed in the nation. In conclusion, what we can say is that we can use sustainability indicators as key tools to assess the recovery plan policies. And the results of our analysis show a significant difference in the starting conditions between the different Italian regions that until now the European Union recovery plan has articulated the Italian version. It doesn't take into account these differences. While water policies once again show the gap between north and south, already well known in Italy, territorial protection highlights a different starting point between Italian regions, which is independent from this gap. And it appears more linked to more articulated regional differences that we need to take into account if we want to valorize, in some sense, all this money that we are using. That's why we think that it is certainly important and necessary to spend the huge resources made available by Europe. And we know that is for the 60% of this huge amount of money, they are in debt. So it is a debt that we give to ourselves. But it is perhaps even more so to do that, to multiply their effectiveness, become not mere expenses, but effective investment capable to offset the debt that Italians have accepted to assume for the next few years, with a view to restructuring the overall organization of the country and making it more resilient to increasingly frequent and unpredictable events that effectively are not covered by this kind of policies that treat all the region in the same way. To do this, it seems to us that the analysis that we have shown need to allocate these resources not only through competitive tenders based on the criterion of the best response to tender criteria, but also on the basis of the different starting conditions that we have now in different regions in Italy. So territorial disparities do not resolve by themselves, as most of the experiences carried out in world in development policies have now taught us, starting from the well-known ones of the United Nations in what were once called least developed countries, up to those of the Cohesion Fund of the European Union. So, in conclusion, we hope that the Italian government will change the way they are using all this huge amount of money that we have taken, put in debt, so in a high debt, the Italian population, taking into account different starting condition of the Italian regions. Thank you.
No, okay.
Huh?
Now it's over.
Okay. Thank you, Francesco, for your talk. Any questions from the audience? Francesco, I would like to ask a question. The study that you have presented us here, and this was about land and water problems.
Yes.
Can the methodology that you developed be applied to other sectors as well? For instance, the built-up infrastructure or whatever? What do you think?
Yes, of course.
Okay.
Yes, because we have now tried to use the same for the other two missions of the recovery of European Union recovery plan in Italy. And we are also sending the results to our regions to try to change the way they are using this huge amount of money. But it is quite difficult because the time is too short. So in this moment, they are more attentive to effectiveness, the efficiency of the entire process, more than how we are using the money.
Okay, thank you.
Thank you very much.
Any more questions from the authority? From the audience, sorry. Got it all wrong because of my sore throat. Right. So thank you, Francesco, but I don't want to skip all the co-authors that you had now that I have the program and the audience here and you remotely. Please pardon me if I don't pronounce the names correctly. So with you, Paola Perchinonno,
Yes, Paola Perchinonno.
Domenico Leogrande, and Samuela Labat worked on this paper, and they received the same credits as you, of course.
Yes, they are with me.
Okay.
Thank you very much.
Here we are then. Thank you for your presentation, Francesco. And I guess we'll move on to the next virtual talk. And I see that Elio is online, isn't it? He's muted now?
Yeah,
Yes, you are.
I'm
Yes.
here. Yeah,
Very
I
good.
was
So
in my office.
I would like to invite you to do the presentation on migration studies with a compositional data approach, a case study of population structure in the capital region of Denmark.
Of Denmark.
Right. And
Yeah, right. Yeah.
Yeah, Denmark, huh?
So I will share my screen then,
Yes, okay, the floor is yours, please.
and I will have.
And name the co-authors later then.
Okay.
All right, here you are.
So here is the presentation. Okay. Do you see here? Okay, I will present our jobs about migration studies with compositional data approaches, and we applied this to the case study in Denmark, in Copenhagen area. So I did that job in Aalborg University with my colleagues Marina Giorgiati, Henning, and Karsten Kepler. So the first thing that we would like to say is like why we need compositional data analysis and what it is. So the reason for why we use this type of approach in this type of studies is that we normally in population geography we speak about percentage of a quantity because we try to avoid the effect of the population of the region. For example, in this picture, we can think, for example, if we don't take into account the population, that the cases of COVID are related with the telephone 5G. That is for sure is not really correlated. So we use percentage in that type of analysis to avoid these effects of the population of the region. The problem and the dark bar is that we put the data in a constant sum. So the data are not really independent. When one proportion increase, another has to decrease to maintain the sum. So the problem is that we cannot apply the standard statistical tools to this data because they are not independent. So we use what is called compositional data. So we have that there are a constant sum with all the elements are positive. That is like percentage. And we have a sample of this in the percentage of rented and owner households in a region, or when we speak about the age of the population in a region with the percentage of young, working age, or elderly population, we speak about percentage in these cases, and we have this compositional data. In our case, we are going to deal with the percentage of Danes, non-Western, and Western migrants. That is the case study that we are using in Copenhagen. There are other types, and we are focusing in this data. So the idea of compositional data is to transform the data in a way that we can apply the normal statistical terms. And they are like what is called log ratios. There are different types of log ratios. All of them are useful. And I will focus more in the isometric log ratio transformation. That is a special case of these log ratios. And in concrete, we are going to use balance. There are a lot of theories around behind this transformation, but the idea and the main idea that I would like to show you is that we transform our data in a way that we can apply standard statistical tools. So this is more or less how balance works. That I'm not sure we don't have much time to go into this, but the idea is that we have when we have 6 components, for example, in our data set, we will have only five balance that we can use for the statistical tools. And here is the formula. So the idea that we have is like, okay, we have data from the population of the Copenhagen area in Denmark, where we have the proportion of Danes, non-Western, and Western migrants. So we are going to analyze that using that type of techniques to show how we can apply that, but we can do that in another data sets. So the first plot we can do is like a ternary plot that we can see the distribution of these three population structures. So we saw, for example, in this diagram, we saw that, okay, most of the parishes and most of the regions have the higher proportion of Danes, but we saw some patterns that Europeans or Western migrants prefer the city center and more non-Western migrants prefer the peripheral area. And we detect very high spot with very high number of non-Western migrants in some regions. So that's helped to interpret the pattern in the population structure in the Copenhagen region. Then we did that with the partition of taking the balance and the transformation of our data. And from the three data that we have the proportion of Danes, Western and non-Western. We have two balance, the balance 1 and balance 2, that we can apply the statistical tools to this one. We will go to do autocorrelation of this data, and we are going to do some cluster analysis to see the patterns in the area. So this, we started with this autocorrelation, and we saw that there are some special correlation in the data depending on this balance. For example, in the balance 1, that we saw that lower values of this balance correspond to lower proportion of non-Western migrants. And we saw that the higher values are here. Does that mean that non-Western migrants try to avoid the city centers and they settle down more in the peripheral area of Copenhagen region, while the Western migrants prefer city center and try to avoid the peripheral areas. So that's helped to interpret the population structure of the area. We also can do some cluster analysis with this balance, and we can differentiate with 4 main clusters in the area. Again, these clusters say that the Europeans or the Western migrants prefer the central areas of the region, and that are the cluster 1 and 2, that with the highest proportion of Western migrants. And non-Western migrants try to settle down in the peripheral areas. So that's helped to also know what's happened with that. And knowing that, we can try to see, try to link if there are some differences in the house prices due to that migration structure. And we can see that the higher prices are in the coast and in the central area of the Copenhagen region, and more peripheral areas like that have lower prices. And we can try to figure it out that there are some links between population structure, where Europeans and Western migrants prefer city center that are the highest prices, and non-Western prefer the peripheral area where the prices are lower. So we can try to associate, and we can try to study these links between population structure and median house prices. We analyzed the clusters. We saw more or less the same, that the cluster were higher proportion of Western migrants, that's 1 and 2, that is are here, have the higher prices. And when the difference between Western and non-Western migrants, these 1, 2 have lower prices than the number 1, and then cluster 4 with higher proportion of non-Western has lower prices than cluster 3. So we can figure it out, and we can try to discuss a little that there is a link between non-Western and lower prices. There are some type of association. However, that is also true that central areas are typically, there are more amenities there and people are willing to pay more. So there are also some prices that are related with location, not only with population. But if we analyze also with a ternary diagram with the proportion of Western, non-Western, and Danish, we saw this difference in the prices that are the clusters, and we saw some lower prices due to the increase of non-Western migrants in the population. However, the important thing is that although non-Western and the migration and the structure is non-Western and Western migrant are related with house prices, they are not independent predictors. So we need to study the house prices difference with all taking into account all these other variables, because we saw that as they are compositional data, they are closest if 1% of if the percentage of one group increase, another percentage has to decrease to maintain the constant sum. So we need to study all together. So with this type of analysis and what we did in the case study, we were able to identify the 4 main clusters. So we can discuss that, of course, the Danish are the main population in the region, but they try to avoid the city center. We saw also that Western migrants prefer the central area of the Copenhagen region, while the non-Western migrants try to increase the percentage increase in the peripheral areas. We can also discuss with that migration patterns help to interpret the difference in the house prices. And we saw some negative correlation between non-Western population and house prices. But the location is also important, and seeing that the more central areas of the Copenhagen region have higher prices. So there are some influence also about the location of this. But this study can help to try to create some hypotheses about what's happened with the population, and if we have some socioeconomic segregation, or why Western migrants prefer one area than another. Maybe because Western are more wealthier than non-Western migrants, they go to the city center. So that helps to interpret and generate hypotheses about this. So with this compositional data, the main point is that the study is more robust than with the normal statistical tools, because with the normal statistical tool, we saw the problem with the independence of the data. So this compositional data analysis alleviate these issues of mainly of spurious correlations, and compositional data also avoid problem with compositional data. That is, if we only focus in a part of the data, they are going to be the same results that if we focus in all the data. For example, if we analyze only and we get samples only from Western and non-Western migrants, we are going to have equivalent results or not contradictory results that if we analyze all the data set with Western, non-Western, and Danish. But the problem is that the compositional data give information about the relative magnitude of the components. So different phenomena can lead to the same relative magnitude of the components. So we need to get more information if we need to do some inference with this value. We need to go a little more further in the interpretation. And another issue with compositional data that sometimes these values are difficult to interpret. There is not a physical value, there are not a physical meaning of this balance, so it's more difficult to interpret this data, and somehow is why some people don't use this balance, although they have more benefits in the mathematical point of view. Okay, thank you for your attention, and if you have more questions or you need to know a little more, you can contact me in these emails, and I will try to help you. Okay.
Any questions from the audience?
I'm trying. Okay.
Any questions from the audience?
Yes, please.
Francesco.
Yeah.
Oh, I have a sort of interest to understand why, if I have understood well, first of all, why you have used just two kind of variables.
So, excuse me, sir.
Why have you used just two kind of variables?
So I understand it's like why I use only two balance.
Yes.
Yeah, well, that is to be honest, it's a case study that maybe is oversimplification because we only have three variables. That is Danish, non-Western, and Western. It's only the idea was only to show how to use that and with a very simple cases. When we do the balance and when we do this transformation, we get always one variable less than the original data because they are ratios between a value and the general mean of the other ones. So with this isometric transformation, we lose one variable. So if we instead that we have 6 proportions, we will have 5 balance.
Okay.
It's the mathematical formula for that. And we lose one variable from the original one, and then we can back transform to the original and the compositional data.
Okay.
And it's why we saw only with 3, we have only 2 balance.
All right. Thank you.
Simplify the problem. Okay, thank you.
Any more questions? I think we only have time for this one. So again, Javier and your colleagues, thank you very much for your presentation.
Thank you for your attention.
And I think we should move on to a presentation in presence, just for a change. And before we start that, I would like to call into the web. Do we have the last virtual presentation? Don't think so. No. Okay. So then we end this session with a presentation in presence. The authors are Apostolos Lagarias, Ioannis Zacharakis, and Anastasia Strategea, and their topic is assessing coastal urban sprawl and the linear city model in the Mediterranean, the Corinthian Bay example. All right, the floor is yours, please.
Yes, thank you. Can you copy it into the desktop or use it from here? Please.
Anyone? Just a minute.
Just time.
Because we need to put this.
Right. So I'm really glad. Hi to everyone. I'm really glad to be here in presence after a long time in a conference. So we're presenting this work that I co-authored with Ioannis Zacharakis and Professor Anastasia Strategea, entitled Assessing Coastal Urban Sprawl and the Linear City Model in the Mediterranean, Corinthian Bay Example. It's part of my recently completed postdoctoral research. So the research target we have set here is to assess coastal urban sprawl and analyze the built-up areas, built-up environment evolving along the Mediterranean coast, in a specific case study in Greece, in the Corinthia region, that leads this pattern of development usually leads to what we understand as an evolving linear city model. So, starting from why urban form is important in urban and regional analysis, we say that it constitutes a key determinant in pursuing urban sustainability. So the shape, size, density, and configuration of human settlements have a direct environmental, economic, and social impact. In urban planning theory, we recognize specific prototypes or models of urban form. So that's why we speak about compact city forms, polycentric, linear, and sprawl, and combinations between all these, of course. So we understand that we need to move towards a more compact city model because it's regarded, it's perceived as a more sustainable form of development as opposed to the urban sprawl model. Because it can contain the loss of natural and agricultural land. It reduces the amount of travel, time, car dependency, energy consumption, and related air pollution. And also, it is considered to be more resilient against climate change. But what is really happening in the Mediterranean right now is a form of intense coastalization. So we have linear form of urban development spreading along the coasts as a result of urbanization, peri-urbanization, and also mass tourism development. So we have artificial land expansion taking place along the coastal zones. This is combined by a process of concentration of population and socioeconomic activities, leading to a special polarization in coastal regions compared to the inland ones. And this is all usually combined with an unplanned and or poorly regulated urban development, usually taking the form of low density development and urban sprawl. Here in the figures, we compare the urban form spreading along the Costa del Sol here in Malaga region, Andalusia. And also to a new project they are initiating right now in Saudi Arabia. It's called the LAN. So this is a planned linear, completely linear city flag. A line spanning along, I don't know, over 100 miles in Saudi Arabia, but it's planned in a different way. And we also compare this to the Soria Mata Spanish urban planner of 19th century, here the linear city. So this goes back as an idea. But let's see what is really happening in the Mediterranean coast. So our work elaborates on the exploration and identification of the linear city concept. We apply high-resolution data for built-up areas we have obtained from the Global Human Settlement Layer database. We have used a set of special metrics to quantify morphological as well as spatial peculiarities and qualities of this linear city type. And we have also applied statistical methods to assess the functional and morphological aspects of the linear city models and classify our region into different built-up typologies. So I will go quickly through all the case study we have conducted. This is the study region in the coastal front of Corinthia regional unit. It's nearby Athens. So it's about 100 kilometers from the Athens metropolitan area. The area is populated by 145,000 inhabitants in 2011, the last census of Greece. It has the major administrative center of Corinthos. It is an area with abundant natural and cultural resources. And the geography and geomorphology is, it presents many particularities as it is connected. There is the Isthmus Canal here, connects two major gulfs, the Corinthian and the Saronic Gulf. So as a study region, we chose to examine just the 5-kilometer zone adjacent to the shoreline because our analysis of the built-up density here shows that after this, how can I close this? Like this? Okay. After the 5th kilometer from the coast, the build-up density is practically minimized. It's practically zero. So all development is pushed towards this coastal front. These are the methodological steps we have used in our geospatial approach. So we see here how we use the data to estimate the spatial metrics and then apply a statistical method to identify built environment typologies to assess this type of development and its functionalities. You can see here a quick definition of the spatial metrics we used. Here we see what these metrics really quantify. So they account for different attributes of the distribution of built-up areas, so we can assess how the urban areas are structured in terms of density, size aggregation, geometry, geometrical complexity and characteristics, and the dispersion connectivity of those areas. So here we can see how the spatial metrics we estimated at a local and disaggregated spatial level of little zones 1 by 1 kilometer. So this is the case study area, and you see how spatial metrics, the distribution varies across case study region for different sets of metrics. And we combine these metrics to produce a smaller set of variables, extracted 3 factors from a PC analysis, F1, F2, and F3, and identified clusters of different build-up typologies. So what is each cluster accounting for? We say that cluster 3 is related to the urban sprawl pattern. It's forming a continuum across the coast. These are areas characterized by low density development. So they have mean coverage of about 10%. They present high PD and ED values. So there's an important fragmentation of built-up areas and high connectivity at the local level. Different typologies we identified are related to rural landscape. So these are areas located further inland from the coast towards the hinterland and semi-mountainous zones. These are characterized by lower PDLSI and ED values, and also are related in many cases to pre-existent rural settlements not affected by the consolidation process, or they are related to some isolated structures and infrastructure. And finally, we identified the more compact areas in our region, which are just a few spots around major urban centers. So we have cluster 6 and cluster 7. We have transitional suburban areas and compactly built urban centers. By combining all these results, we have identified, we have mapped here, you can see how this linear city spreads along the case study area. And as a final step, we have tried to examine, to combine the morphology, this morphological analysis we conducted with an extra set of variables, trying to assess how this area functions and the accessibility related to major transport infrastructure, local road network, distance from settlements, population density, and also some geomorphological characteristics like elevation. So we have mapped these variables also along this coastal front. And finally, we have conducted a correlation analysis to see how the F factors describing the morphological characteristics of the built-up environment are related to the other set of variables we have estimated. Our major finding is that these urban sprawl areas, the cluster 3 areas, are in close proximity to the transportation network. They lack a positive relationship with urban facilities, however. These are areas really close to the coast, and they form this type of linear city. But our analysis shows that these areas do not actually function as a city which is well structured and backed up by urban facilities and really connected at the local level. So we recognize that escalating urbanization trends within this complex and uncertain environment we face nowadays constitutes a huge challenge for planners and policymakers. Coastal urban sprawl is an alarming phenomenon. We need to handle it. We need to take action to contain urban sprawl. Linear cities spread along the Mediterranean coast, and we need to analyze and understand how they are structured and how they function in order to intervene and to plan to move towards more informed policy decisions that could include, for example, zone regulation protection, building rules and restrictions, design of adequate public space, provision of efficient services and infrastructure, and move towards what we understand as a compact city model, which is more sustainable and resilient for the future. So, thank you.
Thank you very much, Carlos. Any questions for this talk? Please, Francesco.
It's an interesting topic. Also applies differences of areas trying to put this in a connection. The urban sprawl represents a component that's an artificial result of the process that process generates conflicts with natural environment. And from my point of view, and I want to make comments in this sense.
Please make speak near the microphone.
Should be also considered in another perspective. Urban sprawl is the effect of urban expansion. Urban expansion depends on the process of where there is a demand for new anthropic transformation, because you have interest, you have development issues, and actually we live a period in which some interest decreases. We experience depopulation, we experience economic decline, and so on. So urban sprawl is something that measures the grow up of the system. Are there any issues in order to understand how this growth up system now has to be reconsidered in order to find a balance between actual needs and former needs in this? This is a Mediterranean issue, of course. Just a comment about that, which in my view is
yes, thank you.
Yes, thank you very much. Very interesting question. In my opinion, the problem is not just that cities are growing, they have to grow. It's the way they grow, and it's the scale of growth. If the scale is not proportional to the actual needs, population growth, this is one issue. The other issue is if we need new housing, if we need new infrastructure, if we need new areas for tourism development, we have to find a place for them, of course, but maybe they should not be in the form of this very low density development that is taking place now. It is consuming vast areas of agricultural and natural land, spreading along miles and miles along the coast. So we need to contain, in my opinion, we need to contain development and set up very calculated plans of our real needs. So it's not a question about urban growth or not urban growth. So wait, how we do it?
Okay, thank you. Any more questions? I think, looking at the time, we're through. It is just for me to sum up this session, thank you. And I think the presentations that we had this morning all show the importance of data. We have various aspects of data, and they're important when it comes to spatial planning, environmental issues, and so on and so forth. So even relating to the last question, you know, what can you do about such a development? You need data to analyze it. And then you can maybe direct it. You need huge planning effort for that. And maybe that happens. Okay, if we all take this from this session, that's, I think, is a good result. So thank you very much in presence and those somewhere in the universe who presented and attended. This ends this session now. Sorry? They're through. Okay.
Maybe
No, they're not here. Huh?
we know.
No. Otherwise, they would have said something. We don't have this first virtual presentation. Yeah, right. They're not there. He's done it. He was here. He
was here. He was here. This is.
No. He
Okay.
did it. The Danish and
this is no.
he didn't turn up. Okay, so we're finished now. This is the lunch break, and hope to see you for the next QM session this afternoon. Thank you.
Okay. Ciao Francesco.
Ciao Beniamino. Ciao a tutti. Grazie.
We and of course, Valentina, thank you very much for helping me. Yeah. All right. Okay, interesting.
That's what responsible to the that's
Okay. Perfect. Thank you. You're welcome.